as you can see a model to demonstrate the process of thermoelectric production. Okay, you can see that how the electricity can be prepared, okay, by the thermoelectric production, okay, process. Now this is our turbine for generating electricity. Okay, as you can see, okay, in the model you have seen there is a turbine, okay, which will generate electricity. The simplest turbine have one moving part. Okay, what? Okay, one moving part as well as rotor blade assembly. Okay, which you are saying that there is a turbine which will continuously what? Okay, rotate. Okay, the moving fluid act on the blade to spin them and impart energy to the rotor. Okay. What? Okay, a blade with warm, okay, it will spin them. Okay, blade to spin them, and due to which impart energy to the rotor. And thus we see that basically we need to move the fan, the rotor blade with a speed which will turn the shaft of a dyno and convert the mechanical energy into electrical energy. Okay, as you can see that mechanical energy get converted to whom? Okay, electrical energy. How? Okay, because of rotation of a blade or a spin of a blade. Okay, you can see that mechanical energy will be formed, and that mechanical energy get converted to warmth. Okay, it will convert to electrical energy, and the form of energy which has become necessity in today's scenario. Okay, so the various ways in which this can be done depends upon availability of resources. Okay, so we will see how various sources of energy can be harnessed to run the turbine and generate the electricity in the following section. Okay, now we will see that. Okay, as you can see here in this model that what? Okay, mechanical energy will convert to whom? Okay, it will convert to electrical energy. Now the thermal power plant. Thermal power plant. Large amount of fossil fuel are burned every day in power station to heat up water to produce steam, which further run the turbine to generate electricity. Okay, as we can see that lot of what? Okay, fossil fuel will burn, and due to which lot of pollution are seen in our environment. Okay, in a power station to generating a heat to produce a steam which will further run to a turbine and generate electricity, and because of whom you can see that generation of electricity can be seen, and the transmission of electricity is more efficient than transporting coal and petroleum over the same distance. Okay, so from that you can see that transmission of electricity is more efficient, okay, than transporting a coal and petroleum to a distinct places or a different places. So therefore, many thermal power plants are set up near coal or oil field. Okay, so near the oil and field and coal field, you can see that many power plant are present, and it will term thermal power plant is used since fuel is burned to produce heat energy, which is converted into electrical energy. Okay, heat energy which are converting into electrical energy. Okay, so this way heat energy is converted to whom? To electrical energy, and this way whole phenomena can be seen. Now hydropower plant. Now the second is hydropower plant. Another traditional sources of energy was the kinetic energy of flowing water or the potential energy of a water at a height. Okay, so this way also what? Okay, electricity will be produced. Okay, source of energy which we say it is a kinetic energy. Now hydropower plant convert the potential energy of falling water into electricity. Okay, just now we have discussed that on depending on that power plant. Okay, power plant in hydropower plant, what we are saying that potential energy of a falling water get converted to whom? Okay, it will convert it into electricity. And since there are very few waterfall which could be used as a source of potential energy, and there are what okay there are only few waterfall through which we can use it as a hydropower plant, and it get converted to potential energy into electrical energy. And hydropower plant are associated with the dam. So hydropower plant is also associated with whom? Okay, it get associated with the dams. Okay, so this way electricity can be formed by the hydropower plant. And in last century, a large number of dams were built all over the world. All over the world, there are number of dams are prepared. Okay, for this concept, hydropower plant concept. And as we can see from figure 14.1, a quarter of our energy requirement in India is made with the hydropower plant. Okay, it get converted to whom? Okay, it get converted to a hydropower plant. Okay, here you can see that. Okay, that reservoir, from reservoir you can see that turbine with dotted. Okay, powerhouse generator. Okay, and that power line will form, and this way what the turbine will rotate, and due to rotation of a turbine, okay, you will see that electricity will be formed. Okay, so in this concept you can see that energy get converted to whom? Okay, it get converted to electrical energy. Okay, and this way hydropower plant will work. Okay, so in order to produce in order to produce hydroelectricity, high-rise dams are constructed on the river. On the river, there are what the high-rise dams are constructed, because of whom you can see that, because of which you will see that water which are falling, it will generate energy, and that energy get converted to electrical energy. Okay, so to obstruct the flow of water and thereby correct a water in larger reservoir, and the water level rises, and in this process kinetic energy of a flowing water get transformed into whom to potential energy. Okay, so kinetic energy get converted to potential energy, and this way whole phenomena will be seen. Okay, so the water from the high level in the dam is carried through pipe. The water from the high level in the dam is carried through pipe to turbine. Okay, and at the bottom of the dam, since the water in the reservoir will be refilled each time it rains. Okay, whenever it will rain, at that time what? Okay, dam water or reservoir of water get refilled, and because of a rain, and hydropower is renewable source of energy, and hydropower which we say it is a renewable source of energy, and this way what? Okay, electrical energy will be formed. Okay, by whom? Okay, by potential energy. Okay, of a falling water. Potential energy of a falling water, we will see that electrical energy will be formed, and we would not have to worry about hydroelectricity sources getting using up the way fossil fuel will get finished once a day. Barabar? Why? Okay, we can see that if the sources of electricity, okay, by electricity is generated by a different sources, in which we have studied that hydro power plant is a very good as well as nice. Okay, because in that you can see that it is renewable. Okay, whereas fossil fuel, okay, the sources by which a fossil fuel is used as a source, that is very what? Okay, that is very finishable energy. Okay, so fossil fuel will get finished one day, while hydropower is renewable. Okay, so it is very important. But the construction of a big dam have certain problem associated with it. The dam can be constructed only in a limited number of places. Okay, dam which we are constructing that are constructed in a limited number of places only. Okay, preferable in the hilly terrains. Okay, that are very preferable for when okay hilly terrains and the large area of agriculture, land and human habitat are to be sacrificed as they get submerged. Okay, which are submerged. Large ecosystem are destroyed. Okay, as you can see that ecosystem are destroyed when submerged under the water in a dam. Okay, in a dam you can see that many fields get destroyed. Okay, because of the submerging of a water in a dam. Okay, and the vegetation which is submerged roots under anaerobic condition are give rise to a large number of methane which is also greenhouse gas. Okay, which is one of the important greenhouse gas. Okay, so large number of vegetation which are submerged root under the anaerobic condition. Okay, and give a rise to a large amount of okay, which gas okay, methane gas which is also known as greenhouse gas, and it will create a problem of satisfactory rehabilitation of displaced people and the opposition to the construction of a Tehri Dam on the river Ganga and Sardar Server project on the river Narmada due to such problem. Okay, due to such problem you can see that oppose are made for the construction of these dams. Okay, Tehri Dam as well as Narmada. Okay, Sardar Server dam which are there in a Narmada. Improvement in the technology for using a conventional sources of energy. Biomass. Okay, now the first is biomass. We mentioned earlier that wood has been used as a fuel for a long time. Okay, in ancient time you are seeing that in ancient time wood are used as a fuel for a long time. If we can ensure that enough trees are planted, a continuous supply of the firewood can be assured. Okay, so from that we can see if we are using wood as a sources of energy, okay, for cooking as well as many other purpose, then first we have to what okay, we have to plant a lot of enough amount of tree, okay, for getting a proper amount of firewood. Okay, so there is a first necessity is that we have to grow a lot of tree, okay, in a different area for getting a firewood. So that is the necessity, okay, in our life through which we will get a proper amount of firewood. So you must also be familiar with the use of the cow dung cake as a fuel. Okay, in Gujarati we say it as what? Okay, in Gujarati we say it as a chana. Barabar? Chana. Okay, which are used for preparing a food material. As a fuel we are using cow dung cake. Okay, and that is also one of the important and necessary sources through which they are using as a fuel. Now given the large livestock population in India, this can also assure us a steady source of fuel. This is also one of the steady source of fuel, and since these fuel are plant and animal product, okay, these fuel are what? Okay, plants and animal product. The sources of this fuel is said to be a biomass. Okay, why we say it as a biomass? Because the sources are which okay, sources are cow dung cake as well as firewood. Okay, wood which we are getting from plant. Okay, so that plant, okay, plant product which we say it as a plant product, firewood which we say it as a plant product, and cow dung cake which we say it as an animal product. Okay, so these sources of fuel, okay, these two sources of fuel are said to be whom? Okay, biomass. Okay, because biological. Okay, it is very biological, plants and animal related thing. Okay, so this fuel, however, do not produce much heating on burning. On burning, okay, a lot of smoke is given out when they are burned. Okay, here you can see that these are those fuel, okay, do not produce much heat. Okay, they are not giving proper amount of heat, but they are giving lot of smoke in our environment. Okay, in our environment you can see a lot of smoke is given out when they are burned. Okay, but they are not giving sufficient amount of heat. Okay, but smoke are lot of that, and in place of heat we can see that there is a limited amount of heat at that. Okay, therefore technologically input to improve the efficiency of this fuel are necessary. Okay, so there is a necessity of improvement of these fuels. When a wood is burned in a limited supply of oxygen, water and volatile material present in it get removed and charcoal is left behind as the residue. Okay? Charcoal burned without a flame is comparatively smokeless and has a higher heat generation efficiency. Okay? So, when we are burning a wood, okay, when a wood is burned in limited supply of oxygen, water and volatile material present in it get removed. Okay, and charcoal is left behind as a residue. Okay, so what? Okay, charcoal will left as home, okay, as a residue, and that charcoal are burned without a flame. Okay, the charcoal which are present, okay, they will burn without home, okay, without flame, and is comparatively smokeless. Okay, the charcoal which are present behind the wood, okay, that is smokeless as well as give a higher amount of heat generation efficiency. Similarly, cow dung, various plant material like the residue after harvesting the crop, vegetable and waste and sewage are decomposed in the absence of oxygen to give a biogas. Okay, so which we say it as a biogas. Biogas will be formed by whom? Okay, cow dung as well as various plant material like residue after harvesting the crop, vegetable waste as well as sewage are decomposed, okay, in the absence of oxygen. In the absence of oxygen they get decomposed and it will form whom? Okay, it will give biogas. And since the starting material is mainly cow dung, starting material is which? Okay, cow dung, it is popularly known as gobar gas, okay, which we said as a gobar gas. Okay, why biogas is also known as a gobar gas? Because its starting material is mainly a cow dung, and that's why it is said as a gobar gas. And biogas is produced in the plant. Okay, once again I am repeating how the biogas is produced. Okay, when a cow dung as well as various plant material like residue after a harvesting crop, vegetable waste as well as sewage are decomposed in the absence of oxygen. All these things are decomposed in the absence of oxygen. Okay, due to which it will give what? Okay, it will give biogas, and that biogas is also known as gobar gas. Why we say it as a gobar gas? Because its starting material is cow dung, and that's why it is said to be gobar gas. Okay, now biogas is produced in a plant as shown in 14.4. Okay, as you can see, slurry will be there, soil are there. Okay, so as well as you can see manure are there, fertilizer are there, okay, digester are there. Okay, this way, and at the top you can see that gas outlet will be there which will give a biogas. Okay, so this way biogas will be formed in the plant has a dome like structure built with a bricks. Okay, as you can see, a slurry of a cow dung and water is made in the mixing tank from where it is fed into the digester. Okay, as you have seen in the model. Okay, what? Okay, slurry of a cow dung and water is made. Okay, mixing tank from where it is fed into the digester. Okay, and further the digester is Shree chamber in which there is no oxygen. Okay, no oxygen will be there in the digester. Okay, now anaerobic microorganism that do not require oxygen decompose or break down complex compound of a cow dung sludge. Okay, so anaerobic microorganism which are present, okay, in the cow dung, they get what? Okay, they will decompose and break down into complex compound of a cow dung slurry, and it take a few days for the decomposition process. For decomposition process they will take a few days. After few days that material get decomposed to a complete and generate a gas like methane, carbon dioxide, hydrogen and hydrogen sulfide. Okay, all these type of gases will be formed, and the biogas is stored in the gas tank above the digester, from the which they are drawn through pipe for use. And by the pipe, okay, through the pipe you can see that these gases are transmitted and inhibited. And which type of gases will be formed? So you can see that methane, carbon dioxide, hydrogen, hydrogen sulfide. Okay, all these get generated. Okay, and by the pipe you can see that biogas plant. Okay, biogas pipe, you can see that gases are removed and it will use. Now biogas is an excellent fuel as it contains 75% methane. Okay, it contains how much? Okay, 75% methane. Biogas, okay, is said to be an excellent fuel. Why? Okay, it is containing 75% of methane. It burn without smoke. Okay, so all these its advantages. Okay, they are showing their its own specialization and advantages, that biogas contains 75% methane. It burn without smoke, leaves no residue like a ash in wood. Okay, in wood you can see that ashes are present at last. Charcoal and coal burning. Its heating capacity is high. Its heating capacity is also what? Okay, it is also high. Biogas is also used for writing. Okay, for writing also it is used. The slurry left behind is removed periodically and used as an excellent manure. Okay, it is also used as a manure, rich in nitrogen and phosphorus. The large scale utilization of a bio-waste and sewage material provide a safe and efficient method of waste disposal besides supplying energy and manure. And do you think the biomass is the renewable source of energy? Now, the wind energy. We saw in class 9 how unequal heating of a land mass and water body by a solar radiation generated air movement, okay, by which you can see that air movement are seen, and cause a wind to blow, and due to which you can see that wind get blow. Okay, once again, unequal heating of a land mass and water body by a solar radiation generate a air movement. Okay, they will produce what? Okay, air movement, and which is said as a wind. Okay, and causes a wind to blow. Okay, and that wind are blowing, that will be used as a source of energy. Okay, and this kinetic energy of a wind can be used. Okay, just now we have talked that the kinetic energy of a wind, okay, wind are blowing, that is its own kinetic energy. Okay, that kinetic energy are used as to do work, and this energy was harnessed by windmill in the past to do mechanical work. Okay, for doing mechanical work this energy will be used. And for example, in a water drifting pump, okay, the rotatory motion of a windmill is utilized to lift water from a well. Okay, from the well you can see that, okay, rotatory motion of a windmill will utilized to lift the water from a well. Okay, because of from the well, you can see that this can be removed. And today, wind energy is also used to generate electricity. Wind energy which are there, okay, that is also used for generating home, okay, for generating electricity. This energy will be formed. And a windmill essentially consists of a structure similar to a large electric fan that is erected at some height of a rigid support. Okay, so this way wind energy will be formed. As you can see, okay, what, okay, in a windmill you can see that one fan will be there. That fan, okay, blade, okay, blade which are present in that fan, that blade will what, okay, move towards the direction of a wind, and due to which it will generate what, okay, electricity. And this phenomena is said to be okay, windmill. Okay, the generation of electricity, the rotatory motion of a windmill, okay, rotatory motion, as you can see that rotatory motion, okay, of a windmill is used to turn the turbine of an electric generator. Okay, electric generator, in electric generator you can see that electricity get what, okay, it will get conserved. Okay, and the output of a single windmill is quite small and cannot be used to commercial purpose, and therefore a number of windmills are erected over a large area. Okay, large area you can see that windmills are erected, and therefore which is known as wind energy farm, and it is commonly said to be what, it is said to be a wind energy farm. The energy output of each windmill in the farm is coupled together to get electricity in a commercial scale, and commercially they will generate electricity. Wind energy is an environmental friendly and efficient source of renewable energy. Wind energy which we are discussing, that is one of the what, okay, it is environmental friendly as well as efficient source of renewable energy. It requires no recurring expenses for the production of electricity. But there are many limitations in harnessing wind energy. Okay, there are certain limitations, okay, which should be there, okay, in a wind energy preparation. Firstly, wind energy farm can be established only at those places where wind blow for generator part or yeah. Okay, what? Okay, it is constructed in those area only where the wind blow for the greater part of a year. Okay, maximum amount of wind blow should be there in that area. Okay, wherever wind farm are prepared. The wind speed should also be higher than 15 km per hour to maintain the required speed of a turbine. Okay, how much speed should be there? Okay, it should be 15 km per hour speed, higher than 15 km per hour. Okay, limited is 15 km per hour, and its speed should be how much? Okay, 15 km per hour. Okay, for maintaining a required speed of turbine. And furthermore, there should be some backup facility like storage cell. Okay, storage cell should be there to take care of the energy need during a period when there is no wind. Okay, so storage cell should be there, backup. Okay, establishment of a wind energy farm required large area of land. Okay, large amount of land should be there. For a 1 megawatt generator, how much? Okay, 1 megawatt generator, the farm need about 2 hectare of land. Okay, how much? Okay, 2 hectare of land should be needed. Okay, for preparing this wind farm. And the initial cost of establishment of a farm is quite high, and the cost is also much high. Moreover, since the tower and the braid are exposed for the vigorous nature like rain, sun, storm, and cyclone, they need a high level of maintenance. Okay, their maintenance are also a high level. Okay, so this way, this all are the advantages as well as necessity, okay, and limitation of a wind energy which we have discussed just now. Okay.